Hello, my name is Peter Stanton. This is my little shop in the garage, Edge Precision. Today the subject's going to be squaring up this aluminum block, and I'll show you how to do it in a precision way. This might not be good for every job, but for some jobs where it requires a precision, I'm going to show you a technique that I use to square things up when I need to have it close and square and close tolerances on the squareness of the part. So what we're going to do this a little different on this video. I'm going to actually show you the end of the video, basically the end result first, and then I'm going to show you the how to do it. So for those that are interested in learning this technique, I'm not sure if I came up with it or not, but it's something that I learned how to do with trial and error, basically, until I figured out how to do this. Because the when I first started machining, we didn't have more precise vices and such, like Kurt vices, and so we had to do things a little different to get things square in the older style vices. So that's what this video is going to be about. We're going to start with a block of material like this, and then I'm going to square up just these faces. The same thing would apply to the ends if you were going to do the ends, but I'm not going to show that in the video. We're just going to show these four faces, and I'm going to first show you after I finished it, and I measured it on the CMM over at my other shop, and what the result was, so that you can see that this actually does work. So that's what the subject of this is going to be about. Also want to say thank you for all the new subscribers to my channel. I'm not sure if it was due to the fact that Randy Richards showed up a set of micrometers that I sent to him, but after he showed that, quite a few more people subscribed to my channel. And I want to say thank you for subscribing, and thanks to Randy for showing my mics, because people found my channel because of that. Truthfully, I'm not real interested in getting thousands of subscribers to this channel, but I'd like to show you things that I've learned over the years. You know, if you're interested in that, and I don't know, I just I felt like I should show some things. I have taught people that I've worked with, but and it's not that I'm an expert at anything, but anyway, I'd like to show a few things, and I think YouTube videos could show people how to do things, because the machining shop business, people are not being trained like they used to be trained with apprenticeships and things, and it's hard for people to find out how to do things nowadays, because there's no formal there's very little formal training anymore in this to teach people how to do machine work. And I think us people that are like older machinists should pass on our what we've learned, whether we learned it the hard way or somebody taught us or whatever, but we should pass it on if we can, and this is what I'm attempting to do with these videos. So let me show you first I'm going to show you the end result of what with this block of aluminum, and then I'm going to show you how to do it. If you want to stick with the video, it's going to be a little bit of a longish video. I might split it into multiple videos. I haven't finished editing the shots that I did, but we'll see. Okay, thanks. Okay, this is the Zeiss CMM over at my other shop, and we're right now it's changing from the master probe that was in the spindle of the machine. And it's going to pick up the probe over to the right there, which is the one I'm using for the measuring of the block. These are ruby tip probes with ceramic shanks on them, in these particular ones. And it's picking up the probe, and see how it's moving up and down, it's balancing the weight of the probe. This type of CMM is a scanning CMM, so it can take just single points, but it can also scan over the part with the probe continually in contact with the part. This type of a head it has, this vast head they call it. So here it's doing the alignment, it's measuring a plane on the top of the part here, and then it's just going to measure a line on this face for the y-axis orientation, and one on this face for the x-axis orientation. Now we're going to come over and scan side number 2 first. Kind of excuse the jerky camera movement, but I'm hand holding the camera because I wanted to get around the part, and there's really no other way to do it in this situation, so that might be a little bit jerky on the video here. Now it's going to scan side number 1 here. And it's going to jump to the back of the part, which is I numbered side number 3. It's kind of hard for me to get to this view because the column of the machine is right in my way. In fact, I got to be careful not to bump it, or it could affect the measurements, and also that it doesn't run into me. And then side number 4. And I ran this couple of 3 or 4 times, and every time you run a measuring cycle on a CMM, you get slightly different results. So I'm going to show you at the end of this little segment here right now. I'm going to move and look over at the screen, but I wasn't sure if you could read these numbers very good. I set myself a 0.5 thousandths tolerance on the tolerance, but see, you can see that it was better than that even. And then here's another shot of another run, so it's slightly different, but it's only different within 1/10 on one of the faces. So this is the end result of what we're going to show you. I'm going to show you. Okay, let's talk about vices a little bit here, just so we'll get an idea of what we're going to try to do and how we're going to square up this part on the mill. The older style vise, we'll call it the Bridgeport style vise, had jaws basically like this, and the vise was built kind of like this, and the lead screw came in here, and of course the handle went out here, and it had a clamp here that clamped there's a slideways on the vise here, and there's a clamp on the moving jaw. Fixed jaw was over here. This is the kind of vise that I started with, because the Kurt style of vise didn't even exist when I started. But this kind of vise has a problem that the jaw, when you tighten the vise up, you got a part in here setting on parallels, and and this jaw kicks up because the force on the vise is this way from the screw, and and if there's any play in this area here on the moving jaw, it kicks up. And also, as with any vise, even the Kurt style vise, it tends to flex the jaw back this direction, the fixed jaw, because a vise is like a C-clamp. Basically, you tighten it up here and it flexes the whole base of the vise back to some degree. Any vise will have this trouble. The Kurt vice's base is just a big base, and it's got the lead screw that comes in here. I mean, if you've taken these apart, you would know this. And it's got a nut on here, and the nut has a piece that comes up. It's kind of like this, and it has a 45-degree angle down like that, and there's a spherical thrust element here that hits in against the moving jaw. The moving jaw is like this. Master jaw, or the fixed jaws here, and your hardened jaw pieces are on there like that. and this hits up against, and it pushes a force downward as well as this way, and it keeps this rear jaw down against the base of the vise. And this is a little bit better design, but it still has similar problems to this vise, and then when you have your part in here sitting on parallels and you tighten this up, the jaw doesn't lift in the back really, but it still flexes the body of the vise, so this master jaw or fixed jaw goes back, flexes back, so you get a situation like this, to exaggerate it, where the jaws are like this to some degree. It's more so in this kind of vise than this one, but you still have the same issues. And the base of the vise flexes. Well, actually, it's going to go, you know, if you're pushing on it like this, the base is going to flex somewhat. Of course, you have it bolted down to the table of the machine, and the machine's table actually helps support the vise to some degree. What I'm going to try to show in this video is a way to square parts up that doesn't depend on these jaws being perfectly perpendicular to the table of the machine. You know, this angle here, in order to square up the part, I should say, the normal way that most people have been taught to, you would face the top side of the part, then you turn it over and you put your good face side against the fixed jaw, and then you face this side, and then you probably flip it around, you know, well, then you got to tumble it over this way or flip it another direction to get your good face side and face the other side, and so on. You go around the block that way to get it squared up. But if there's any angle in this jaw like this, to exaggerate it, you're going to actually accumulate an error as you go around this block facing off the sides to try to get all these corners at 90 degrees to each other here in your piece of material. So there's a different way to do this. I wasn't actually taught this way. I kind of learned it by experimenting on it. I don't know if this is a way that other people do it. It's a way that I've always done it. I don't do this on every part, because some parts don't require this kind of precision to do this. But what we're going to do, let me turn the page here. We're going to let's blow this up a little bit. So let's visualize our stock like this, and our vise jaws like this. And then we got the base of the vise here. Can't draw kind of good this way, but you know, and we got our fixed jaw down here. This would be Kurt style vise, let's say. Now we're going to set the part on parallels, and we're going to set it up kind of high up in the vise. And I know this kind of sounds contrary to what you might think is the right way to do things, but we don't want, no matter where these jaws are oriented here, we don't want it to influence the part. We want the part to set on the parallels instead here. And of course, this all depends on your vise being perfectly parallel to your table, or as close as possible to your table. So that you need to check and make sure that's true, and that your parallels are both the same height within the accuracy you want to square your part up. You know, hopefully they're within the same height, within a few 10,000ths of an inch, and the vise is flat and parallel to the table. Otherwise, this introduces error to this method. But other than that, you don't depend on the vise being this actually used to work in the old Bridgeport style vices, which is the way I learned how to do it initially, because a Kurt vise back then didn't even exist, and so we had to learn a different way to do it, and this was one way to do it. And what we're going to do is we're going to face off the top of this part. We're going to take two little fine cuts on the side here with a end mill like this, This is our spindle, and we're going to face that top off, and then we're going to flip the part 180 degrees. So we have, first we're going to measure the width of this very precisely, the width of that here, of what we've machined, because we need to know that number. And then we're going to flip the part over, and we're going to put it in the back in the vise and tap it down so that our cuts are down here. And then we're going to center our setup over the jaws, over the machined width of our part, and we're going to face the other side of the part and take these two cuts in the other side and mic it over here, and assuming that we're centered over here, we'll mic it till it's the same width, and then we have these two cuts even with each other and at 90 degrees to each other on all these corners. And as long as this cut is parallel to this cut, then we can tumble it over in the jaws and put it down and hammer it down so that our parallels are tight, and we can face the other two sides, and we should have square corners all the way around within the tolerance of the difference of our parallels and the flatness of our vise. The jaws of the vise don't come into play here. The only thing we have to be careful of is after we do the first side, when we flip it over, we have to center quite precisely on here so that when we machine the other side to the same width, that we know we're directly above these faces that we faced on the side with the end mill. Other than that, everything, that doesn't depend too much on the vise being accurate. The vise, of course, has to, if looking at the top view with the jaw, it has to be parallel to the x-axis of the machine in both directions. You know, you got to get this indicated in, which is just what you normally do when you put your vise on the table, because that also could introduce an error this way, looking at the top view of this in our setup. So this is what we're going to try to do, and I'll show you how it's done, and I'll show you on the machine so we can see you know, firsthand how it's done. And this is the way that I've used to get close tolerance squareness on a part. Not every job requires this, but when you do have to have something square, this is one way to do it. It's probably not the only way, but it's a way that I've used in the past, and it's worked for me. I'll also show a little bit about holding parts in the vise and how certain ways of holding parts can introduce error to your setup, if I can. So let me get the machine ready and going, and then we'll look at what we're doing, or actually how to do this on the machine. So I'll be back in a second. Okay, this video is getting kind of long. Sorry for the noise. I got this air conditioner in the shop here, and it's pretty much right next to the computer and bench, and it's really hot here in Houston, and it's kind of hard to work without air conditioning. So there's kind of it puts background noise into the video. I try to turn it off some of the times, but sometimes I forget. But I'm going to make this the end of the first video, and then I'm going to show in the next video how to actually do this on the machine, what I've showed here. And so I hope you take the time to watch the next videos and see, and maybe learn how to do this. I think it'd be a good thing to learn how to do if you want. So watch the next video.